Magnetons. I think we're actually starting to understand how they work. We conjecture ahead.
Although this is going to be weird, and it's going to be about a different.
Title of the conference was something like "Ground Truth" or "Turtles All the Way Down," and so it seems as though there's one Ruliad. I don't think it rules them all, and it might be just hyper-rulial turtles all the way down.
Yes, it's on the back of an infinite number of hyper-rulial turtles.
Various people are commenting on the outrage of hacking the universe on a MacBook Air.
Hey guys, what's going on? Memes here. So, of course, we're back from the monastery. But before we left, there was a question that I had for Thad. Yes, that rhymes. But basically, we done the calculation of the Bohr magneton and the nuclear magneton. They did not match the measured data on NIST.gov. So, I asked Thad about that. Apparently, they had updated the numbers. So, we will, just because given the number you're looking for, if that's not there, maybe we should update it. Because data is good. And that is the science. At least I hear. At least it's the method we're supposed to use. We'll see. But, yeah, so we flipped through the book the other day. And, yeah. We had some stuff here. I think this is on page 3 or 4. It's on like page 3 of what I had been using. All right. So we went back and we updated it. So what is this monstrosity here? Well, this is essentially this little equation right here. I realize. Okay, what we got here? Okay, it doesn't matter because all you change is either the mass of the electron or the mass of the proton. It's essentially the same geometric argument. So we have our Joe1 here from the hyperbolic vortex equation and stuff. Links are in How I Stumbled Upon the Best Theory of Everything Yet video. And then you multiply that by the boundaries, because that's our primary action. We multiply it by the boundaries, and for this, it happens to be Planck length. Oh, we'll bring a thing up. All right. Okay, so what was I just saying? This is the value of Joe1. So if we square that, I claim, we get the fine structure constant. That's pretty neat. And, hey, Whitechapel, thank you for joining, my friend. This is going to be really quick, because it's going to be a bit of a review with the correct answers, or at least within our margin of error. So, what is this? This is the first answer to the hyperbolic vortex equation. Divide by 2. Cool. As we can see here, that's the Planck length. We square it. So, this over here is the Planck charge. This is the Planck mass. This is the Planck time. See, I got it right this time. It's 10 to the negative 44, but it's in the denominator. So that's why these are positive numbers. Hey, welcome, Parrothead. We're going to do our homework that we've been meaning to do, and it's done correctly. I also have the link saved for a lot of these things, so it's a heck of a lot easier. And I can actually kind of communicate what I believe to be going on to the best of my ability, because I'm an intern with the Physics Monastery. I think I updated my Facebook, so it should be official now. It's on the internet. But where are we? Okay. And yeah, this is Planck time. And this is the mass of the electron. And again, they're in the denominator, so all this stuff is positive. And then those are... Oh, no, we're dividing it. That is... Nope, excuse me. This is negative, so anything that's negative normally in the... This is how it happens. You just plug it in there. What they'll do is, depending on the power and everything, we'll either put in the numerator or the denominator. But it gives us the numbers. Oh, and this is the mass of the electron. The link is in the doobly-doo below if you want to click on it. I've done a video the other day. All right. So this constitutes primary action. And then we got our boundaries here. So, again, according to the binomial factorization equation, the next step is we have 1. And we have plus our terminal action, and then we multiply it by the break in inverse symmetry. I think that's what we're calling it now. Basically, that's the Planck Planck length times Planck mass divided by the Planck charge squared comes out to be exactly 10 to the negative 7, or essentially 1 ampere, the magnetic permeability of free space. At least that's what I read on Wolfram Alpha. And that was made by a lot of smart people. So what we got here? So, okay, we have the action in and of itself. So this is our 10 to the negative 7. That's how it comes out here. And then our action is 2 pi. So that's a circle. We got a circle raised to the negative 1/3. For those of you that have been following, if you take 1 and you raise it to the negative 1/3, or negative 1 raise it to the negative 1/3, you get the imaginary golden ratio. I think that's pretty neat. And then that's divided by J1 squared times J2 squared. This is the break and scale symmetry here, and it gives us a fantastic number. Hey, Snacks, you're going to have to remind me when PAX is. We'll see you there. I'm sure Gator will be fine. But, where are we? Okay. So, oh my God, we've been critically hit by all the numbers. I apologize. Yes, there's more numbers here. At least the pleasant background isn't as intense on the eyes. Yes, I am a savage and don't always use night mode. Okay. This was the updated value of the Bohr magneton. So we have it calculated out to be approximately 9.27401000783 with 28 in the error bar. So go up or down the last 2 digits by like 28. All right. So that could also affect this digit technically. I think that's within the error range. And that's times 10 to the negative 24, and that's joules to the negative 1 Tesla. Or essentially it comes out to be, at least according to what I have written down here, Planck length squared times Planck charge times Planck mass divided by the Planck time, again, not Planck temperature. We use a big T for that. And that's multiplied either by the mass of the electron or the proton, depending on if you want the magneton or the nucleon. Excuse me, nuclear magneton. Should get our words correct. But, ooh, that sounds fun. Monster by Night. I'll probably pop in very briefly. Sorry. So nuclear magneton, exact same thing, except you take this thingy. That's right here. Mass of the electron, and you swap it out with the mass of the proton. So, and that gives us a number of 5.0507837461 with error bars of approximately 15 times 10 to the negative 27 joules per Tesla. Again, Planck length squared, Planck charge, mass Planck, Planck temperature. Excuse me. See, I made the mistake again. Planck time times the mass of the proton for this. Okay. So it's the same geometric action. Okay. So obviously we know I'm totally full of hot air. I'm very loud. I cause a lot of feedback. But let's take a look at the numbers, shall we? Oh, we shall. Because now we're going to start to tell a story. All right. So the number we get here after this gigantic monstrosity we were just going through again. It's much simpler when you just write down notation there. What's this number right here? Because we got the mass of the electron in that one, so that must mean this is the Bohr magneton. All right. 9.2740100782149 times 10 to the negative 24. Again, it's a geometric derivation. Go as many decimal places as you would like for predictions. Okay. So what's the code data result for the Bohr magneton? Oh, 9.27401000783. Number of bars of 28 times 10 to the negative 24. 9.274 010 010 07 0783. 0782. We're off, but well within the margin of error. I think that's pretty neat. All right. So what happens if we want to do this other guy? What's this called? I'm sorry, I'm assigning gender. I'm not sure of the nuclear magnetons' preferred pronouns. But, okay. We got 5.05. All right, so 5.050. We go up here. Since I had already swapped it out to save time, we're going to click forward in the browser tab. Ah, this number here. So we swapped out mass of the electron. The mass of the proton's approximately this, 10 to the negative 27. Okay. What numbers do we get? Big money, no whammies. Not that there's anything wrong with whammies, but consent matters. 5.050. 5.050. Okay. 783. Oh, wrong one. 783. 7461. 7461. 7460. That appears to be well within the margin of the error. My friends, this appears to be a geometric derivation of the Bohr and nuclear magnetons. I think it's pretty neat. Hey, listen, I said I was going to ask a question, and part of me was like, oh, is this going to throw off the model or anything? No, because if there's a good model, it should tighten up the better the data points we get. That's why experimentalists are key. Yeah, yes. Yammies. Is that how you say? I don't even know anymore. Words can be hard. But we try. Why? So we can improve. It's kind of like playing a video game. Maybe you get some experience. If you're fortunate enough, maybe we'll level up. Hey, that's what I got all for right now. Peace out, everybody. Be safe. Take care of yourselves. It's a wacky world. I think we're starting to pass through the ether, so to speak. Unintended. Take care, everyone.
Have you guys checked out the Memes of Destruction's channel? He's an interesting dude. I like him.